Hey dude, so in 1.6 we're going to talk about relations. Alright, relations are kind of the basis for all functions, all graphs, all equations, everything that you see in math is, or at least in algebra, is based on this more general idea called relations. Okay, so what we're going to learn to do today is represent relations. So this is this real broad idea, and then we're going to specify it more in 1.7 and 1.8 with specifically functions and then linear functions. Okay, so in order to understand relations, we first have to understand the coordinate system. So the coordinate system is the way that we graph two-dimensionally relations. Okay, so this coordinate system is made up probably of some things that you know. All right, there's usually the coordinates are made up of x and y. Okay, x's are the horizontal axis, so this is called the x-axis. Okay, and the y is the vertical. That's called the y-axis. Okay, now we also have this thing is broken into quadrants. So that's quadrant 1, quadrant 2, quadrant 3, and quadrant 4. We use Roman numerals to describe those quadrants. So our x's and y's, right, this is the positive x direction, right? To the right is positive x, to the left is negative x. Up is positive y, down is negative y. Okay, and that's the general idea of the coordinate system. So we can plot points based on this two-dimensional plane. All right, now a relation is any set of ordered pairs. All right, so an ordered pair is actually just that xy. All right, an ordered pair is just a point on that coordinate system. Okay, so a relation is any set of ordered pairs. Set is just more than one of them. Well, I guess it could be one of them, or even less than one. It could be 0. Okay, so I'm going to show you just different ways that we can represent relations. Right? First way is just as a set of ordered pairs. So we just have 3 ordered pairs here. So this is one way to represent a relation. Another way is to represent that in a table. Okay, so if you create a table, we've got split our tables up in x's and y's. Right? So the x's we've got 1, -2, and 0. And the y's that correspond with that, well, 2 goes with 1. 4, and -3. Okay, we could also graph this relation by putting our plane on there, going over 1 for the x, right? The x is the 1, and up 2 to graph the first one. The second point is going to be to the left 2, because -2 to the left for the x, and up 4, so add 2 more to that. Pretend that those are even, trying to do them as evenly as I can. And the last one, we're moving left to right 0, and we're moving down 3. Okay, so that's the graph of that relation. It's just those 3 points. And lastly, there's this thing called mapping. Okay, so this mapping is taking the domain and the range, or the x's and the y's, and basically drawing arrows between them. Okay, so I've got the domain and the range. Okay, domain is the x's. Domain is the same as x, and range is the same as y. Now, in these little bubbles, I put my x's in there, -2 and 0, and my y's. Now, they don't necessarily have to be in that order. Let's actually rearrange them to be in increasing order for both of them. Okay, so we have -2 first, then 0, then 1, and then -3, 2, and 4. Right? Now, the beauty of this is you can represent these by you actually just draw the arrows to show the connections between them. So 1 goes along with 2, 0 goes along with -3, -2 goes with 4. So you can see the connection, you can kind of see patterns that way. Right? So those are 4 different ways to represent a relation. Okay, last thing we're going to go over before we jump into the examples is just what the difference between an independent and dependent variable is. You probably learned about this a lot in math, but also in science. Okay, the independent variable determines the output. All right, it's totally on its own, doesn't depend on anything else. It's the domain, it's our x's. Okay, the dependent variable is determined by the input. So the independent variable tells you what the dependent variable is going to be. That is the range. So the x doesn't depend on anything. The y depends on the x. Alright, and number 1, we're going to identify the independent and dependent variables. So in warm climates, the average amount of electricity used rises as the daily average temperature increases, and then the average amount of electricity used falls as the daily average temperature decreases. So we understand that the daily average temperature determines what the average amount of electricity used is. So that means that the daily average temperature is going to be our independent variable. Okay, and the average amount of electricity used depends on the average temperatures. That would be our dependent. Okay, in B, we've got the number of calories that you burn increases as the number of minutes that you walk also increases. So the number of calories that you burn depends on how many minutes you walk that day. So the number of minutes, okay, is our independent variable. And the number of calories you burn will be our dependent. Let's check out some more examples. In number 2, right, we've got this relation. Remember, a relation is just a set of ordered pairs. So we've got these 4 ordered pairs, 1, 2, 3, 4. All right, we're going to express them as a table, graph, and a mapping. Now we're going to determine the domain and range of the relation. Okay, so first, as a table, do our x and y. We need space for 1, 2, 3, 4. That's perfect. So our x's are 4, -2, 2, and 0. And our y's, 3, -1, -4, and -4. Now normally you would write this in increasing order, so I would rearrange this to move this one to the top, and then this one, and then this one, and that one at the bottom. Okay? The graph, okay, I just graph all those points. I've got my xy. So for 4, 3, I've got 1, 2, 3, 4. 1, 2, 3. Plot the point. -2, -1. Plot the point. 2, -4. Plot the point. 0, -4. Plot the point. So I see all of my points on there. That works great. And the mapping, x and y, their domain and range. All right, let's write them in increasing order for the x's this time. And for the y's, actually. -4. You don't need to write -4 twice here. You only need it once. All right, and now the arrows. So -2 goes to -1. 0 goes to -4. 2 goes to -4 also. And 4 goes to 3. Okay, so those are 3 different ways of representing that same relation. Now, the domain and range. All right, the domain is all the x's. So the domain is the set of, we use the squiggly parentheses. Alright, so we have, the domain could be -2, 0, 2, or 4. And the range can be -4, -1, or 3. Okay, that is all for number 2. And number 3, alright, we're going to interpret this graph. We're just going to take a look at it and just explain a little bit about what's going on in this graph. Okay, so we know that we're working with days of the week is our independent variable. So time is probably a better way to put that. And the temperature is going to be our dependent variable, right? Because the independent variable is the x's and the dependent variable is the y's. Now we see that the temperature spikes during the day and it drops to its closest low overnight. Spikes during the day, drops during the low at night. So that's pretty much what's happening here. Spikes during day, plummets during the night. And we're talking about the temperature. Okay, so that's pretty much it for this section, and we'll check out some more stuff in section 7.